Okay. Okay. Yeah. So I will start with the workshop now. Okay. So this workshop will basically we'll go through a few things. There will be important to a physicist in your experimental physics. I mean, by in the context that I'll be doing, it will be in the context of experimental physics. Like, let's say you take some data, you want to do some curve fitting, you want to plot your results. Everything I teach here today will be important for that. Okay, so first thing we'll need some packages. We'll need Numpy for your arrays. Then the math package is just to show an example later on. Pandas will be used to import data from the Excel file. SciPy.optimize curve fit will be used to fit your curves, fit your functions. The special is just to introduce some special functions, and matplotlib pyplot will be used for plotting. So we just import all that. Okay, so so for this workshop, I'll just introduce some notation, because in your function, sometimes it will take in different arguments, and then some arguments are optional. That means that we can leave it out and the function will still work because the function by itself has some default value. So in this case, I will indicate the optional arguments by this notation. I'll put the equal sign and the default value it will take. If I never put the equals, recorded already. If I never put the equal sign and default value, this means that you have to specify this argument. If not, the function will not work. Okay, so the first thing I want to introduce is Numpy Arrays. So if you have used Python in some form, you should be familiar with Python lists. So arrays is just something similar to lists, but we can only have numbers inside them. So we cannot have things like string, booleans inside it. Only numbers such as integers and floats. Yeah. Then if you want to visualize a 1D, is it too small for you? If not, I can zoom in. Yeah, if it's too small, just say. Then if you have any problems, like if you got questions, just stop me. Just stop me when I say when I'm talking. If not, I will just continue on. Talking with a mouse a bit difficult. Okay, so some useful functions to define arrays is mp.ones, which is just to create an array filled with ones. Then similarly, we have mp.zeros, which is just to create an array filled with zeros. So for this shape here, is basically saying that how long you want your array to be. Let's say you want an array with 5 elements, all filled with ones. Then we'll use mp.ones 5. Yeah. Then other than this, let's say we want to have a range of numbers or a range of integers, we can use mp.arrange. So we will need to specify at least minimally the stock. But then usually we want to specify the start integer, the end integer, as well as the step size. Yeah, so it will start from the start and then it will not include the end point. So that's why there's the bracket. Yeah. Then let's say you want to have evenly spaced numbers throughout an entire interval. We have mp.linspace, which will give you a range, which will give you a interval filled with numbers from the start to the end inclusive. And by default, there will be 50 points in this interval. Then if you want more, let's say you want to plot something that is more fine, we can always increase the number of points or reduce the number of points if it's too many. Yeah, then in this cell is some examples of the different arrays, and then I just print it out for you to see. So mp.1 is 5 expected result, an array filled with 1 with there is 5 long. Then mp.07 is an array filled with what are zeros and 7, and then similarly for arrange and linspace. So you can just play around with the values and see what results you get. Okay, so earlier I introduced the mp.ones and mp.zeros, right? And then it has the argument shapes. So earlier I just said that the shapes is just an argument telling the function how long you want the array to be. But then it's a bit more general than that. Sometimes we want to have a 2D array or a 3D array. Then in that case, we'll need to specify 2 or 3 numbers respectively. So you need to specify it in a list. I think a list format will work, but in this case, I use a tuple, which is just two numbers like this. So it's a bracket. It's just like bracket 2-3. So I say for my first dimension, I want to have a size 2, and for my second dimension, I have size 3. So that's how. So I will put like okay, maybe I just like, in this case, I have np.1 bracket 5, 3. So I say I want a size of 5 in my first dimension and a size of 3 in my second dimension. Then if I print it out, you see I get a 2-dimensional array that is 5 by 3, 5 columns and 5 rows and 3 columns. Yeah. So shapes basically will tell you how big your array is. Then the next thing I want to talk about is how to generate a arbitrary array. So earlier it's only the array in a certain format. But let's say we want to have an arbitrary one, we can convert a nested list or a list into an array using the np.array function like this. So you can just run and see that if I convert this nested list of 1, 2, 3, 4, 5, 6 into an array, we can see that the shape is 2 by 3 because it's 2 columns. 2 rows, 3 columns. And then we can also just print the array to see that you get a 1, 2, 3, 4, 5, 6. It's converted from a list to an array. Yeah, then you can just then we can just remove this the inverted commas there to run a section in the middle, just to show that when you want to convert a nested list to an array, it has to be the same shape. If not, they will give you an error. Yeah, it will give you an error. Basically, you just need the list inside the nested list to be of the same size. So in this case, since our first list is of length 3, our second list will also need to be of length 3. Okay, then the next thing will be what type of operations we can perform on this array. So we can do our normal arithmetic operation, your addition, subtraction, multiplication, division, and modulus. In this case, when you do these operations on 2 arrays, you will do it element-wise. So with our earlier array, we can just run this cell and then we can see what arguments we get, what results we get. Yeah, so I think if you perform the operations element-wise, you should expect to see these results. So you can just play around and see, like if you get anything new or whatever. Then if you got any questions, can always ask me. Okay. Oh, right and okay. So so print right can take multiple arguments. So in this case, I put 2 arguments. So I print the first argument followed by the second argument. This second argument, the /n basically tells it to do a new line. So basically, it's like you see this line here. Because I put the /n here, so there's a new line here that is just blank. You can just you can try removing like this part here and only print like list array multiplied by list array, and you will see that the line, the new line, the empty line here will disappear. So the /n there is just so that it will look nicer. Yeah, then the last thing I want to talk about arrays is, let's say you want to have you want to fit the array into a function. Let's say you want to exponentiate a matrix. We can do this like using the numpy dot exponential function. Okay, I mean by exponential matrix just means that I take the exponential of each element of the matrix of the array, not like really exponentiate it, but exponential each of the elements. So in this case, we can just do np dot exponential. Yeah, then you also need to make sure that your function can actually take in an array as your argument, because some functions, like for example, we can also exponentiate numbers using the math dot exponential function. Yeah, like this particular function belongs in the max package. Then if you run it, you'll realize that you get an error out because it will only operate on numbers and not on arrays. So we can just remove this line. We can just remove that symbol and then run it, and then you see that it gives you an error. It gives you an error telling you that this function can only take in numbers as argument and not an array. Yeah, then for pandas, because there are many different formats for Excel when you key in your data. So I won't really spend a lot of time here, but just to tell you that it's possible to convert an Excel, or it's possible to import data from Excel into Python using the pandas package. Yeah, so you can always just open the Excel file that I sent, the sample Excel values, and then see how the data is like. So just showing you that you can read the values into Python and then convert it into an array. Yeah. So if you see this data array, will be just be all these values here. Then like the first column in it will be all your distant values, and the second column will be all the function values. Then we'll need to then we want to actually just separate this into two separate arrays. Then we can just do it in this particular way, where the two dots there just say to like sort of run through all possible values in that index. And then we are sort of fixing the second index to be 0. That means we are looking at the first column and then we are running through all row values of the array to get the distant values. And then we are running through all row values and fixing the column to be 1 to get all of the function values. Yeah, so if you print it out, you will see that you get these two arrays respectively. Then, okay, so other from Excel, sometimes you will encounter your data in a text file. So maybe in your experimental physics module, this will not be so common, but let's say you go and do an attachment to a lab. Sometimes certain equipment will give you the data in a text file. So we will also need to import the data from a text file into Python to do our curve fitting or whatever analysis. So in this case, we can use the numpy gen from text function. There we simply will tell it what file we want. And then like, let's say if you got some header telling you this column is what values, the second column is what values, to skip a few lines. In this case, it will be the skip header. So we want to skip the first row, and then we can also specify some delimiters. By default, is any series of blanks or spaces will be taken as the delimiter for the different columns. Then the sample values is the same data that we have in our Excel file, just that I converted it into a text file. Then if we run it, we will see that we can get these values, which is basically what is in the text file, and then you can separate it into two arrays using the same way that we did for the earlier example. Okay, then you come to one. I think one of the two most important things in this workshop, which is how to do curve fitting. Okay, so Excel can let you do some simple fitting, like maybe to some linear function, polynomial function, and maybe exponential and logarithmic analog function. But sometimes we will see some more exotic function like your hyperbolic functions or your error functions, and we want to fit to that. So Excel can't really do that. So in this case, we'll need to use other programs like Python to do our curve fitting. So one of the ways that we can do it, like there are other functions within Python, but I think this is the most general, is the scipy optimize curve fit function. So this function, we need to specify what function we want to fit to, the X data, the Y data, some initial guesses, the P naught. The sigma will be the uncertainty that you have in your Y Y data, And then the bounds is basically saying that I want like the guess parameters must be within a certain range. Yeah, so this is actually quite a good function, but it won't be able to guess the function by itself. We will still need to be able to know what the initial function, like we need to know what function we want to guess in the first place. Yeah, so this example I show you here is the hyperbolic cosine function. Yeah, then I will generate some data by first generating the x values using the lean space function. Then after that I can generate the y data in the following manner. Then the np.random.ren is just to add some noise to the data so that it's not a very nice fit exactly. So there will be some uncertainty in the guesses. Yeah. If there's anything that you're unclear here, I think you can just tell me. Yeah. Then the curve fit will return you two things. One is the pop and peacock. Pop in this case will just be the parameters that it gets for you. And the peacock will be the covariance matrix of your parameters, but we don't really care about the entire covariance matrix. We will only care about the diagonal elements, which will give us the variance of the parameters. Then from the variance, you can always take the square root to get back the standard deviation. Sorry, this one I'm also not really sure because I don't really have a lot of stats background, but it's something related, something to like it's a covariance matrix. Like you can Google if you're interested, but usually I just ignore them and only take the diagonal elements. Yeah, so if I run it, then like this is just a quick plot that I just show you that the dots are all is all our x and y data, and then the line itself is the best fit line. Like the best fit line in this case will be the line that gives us the least square, like the least square deviation, which is like if you take like okay, like for each point, right? This one. Oh. Okay, so okay, wrong slide. Okay, like the least square in this case is we want to minimize the distance from the vertical distance from the point to the line itself. So we will sum up all of this distance. We will sum up all of this distance, and then then the function will minimize the sum of all these distances to give you your best fit line. Yeah. Yeah, then there are a few things here that maybe I will talk about. Like you see here for a pop, instead of saying like pop 0, pop 1, pop 2, and pop 3 to specify all the guess parameters, right? What I did is put an asterisk there, which is just to unpack the list. So you will just know to unpack the list into the different list elements. So you don't need to write pop 0, pop 1, pop 2 again and again. You can just put asterisk pop there, and then it will do it for you. Yeah. Yeah. Oh, like this star here, right? Yeah. Okay. Yeah. It's just basically to unpack the list. So let's say your list has 0, 1, 2, right? Then let's say we want to print out the list element 1, list element 2, list element 3. We will need to put like list 0, list 1, and list 2. But it gets very repetitive and very tiring. So instead of doing all this, we can just do this as the argument, and then it will know to sort of put all the list elements there for you. Yeah, like I know it works, but I don't know when it doesn't work. So Just try. If it works, it works. Yeah, so this is another example, but using the error function. Yeah, so this example is just to show you that sometimes we will need to specify the initial guesses and the bounds for it to be able to do for the function to be able to give you a guess at the parameters. If not, it will either it will take too many tries and then give you an error, or it will give you values that don't even match the function in the first place. And then also in this example, I also introduced some error into the y data. Like I said, my y data has an error bar of 1, as a standard deviation of 1 maybe. So it's which I specify in this line here, the y standard equals to mp dot once. Then I put the shape there just to say that how long the data need to be, because it need to be the same length as your y data in the first place. Yeah, then okay, maybe I don't do the correct one first. I show you the wrong one. So let's say we naively put, we want to fit the error function for this x data and y data. And then we run it. Yeah, so in this case, it can't give you any uncertainty in your, that's what the error telling you. It cannot give you any uncertainty in your parameters, but can still sort of give you some guess as what the parameters could be. Then if you plot it, you can see that the best fit line isn't anywhere close to the actual function itself. So in this case, it's we'll need to use some physical intuition, or maybe when you do the experiment, you already know some guess as what the possible parameters could be. So then we will need to be able to give the function some initial points, or maybe to restrict the search, to restrict the possible range of the parameters. In this case, I provided both here. Yeah, so here, the P dot here is basically the initial guesses for the values. Then the sigma is the standard deviation in the y direction. Like if there's uncertainty to each point, you should include it so that it will take into account when it's fitting the parameters. Then the bounds, so the bounds there is 2 lists. The 0, 0, 0, 0 list is basically just saying that this is all my lower bounds. Then my 10, 1, 120, and 30 is the upper bound for the possible parameters. So it will guess the parameters only within this range. And then if we run it now, we see that we can get a curve that is a better fit to the points that we have. Okay, and then we come to the last part, which is how to plot this graph using pyplot. Yeah, for today, I will only cover one-dimensional graphs, but if you're interested or you need to plot two-dimensional graph or even do animations in the future, know that Matplotlib can do all these things for you. Like you don't need to go and learn a different program just to do all this plot. Everything can be done within Python. Just run this cell. This is just a cell for you to control the font size. Like if you just want to have a quick visualization, this is not necessary, but if you are plotting a graph for maybe a lab report or something, I would suggest that you include this in to have an easier time in controlling the different elements in your graphs later on. Yeah, then I will just introduce the different parts of the graph. So the entire thing is called the figure, and then the smaller axis with all the plots is your axis. And within a figure is possible to have multiple axes, like you can have 2 plots on one figure, or like 4 plots on one figure. I will explain later on what is it. But then, yeah, so just know that you have the figure, you have the axis, you have your axis, and then you have your axis itself. So like these are the components to a figure. Yeah, then I think I just go through and then explain along the way. So the first thing we need to do is to create our figures and axes. using the subplots function. So we need to specify the number of rows and the number of columns. That means how many axes we want. So in this case, we want to have 1 by 1. So it's rows equals to 1, columns equals to 1. And then we have the figure size argument, which is basically just to say how big we want our figure to be. If you're just plotting a 1 by 1, you don't need to specify the rows and columns. That is optional. And then if you don't really care about how big your figure is, you can also omit the figure size. Then afterwards, let's say if you want to do a scatter plot, which is just to plot all the points, we can use the ax.scatter. Yeah, so you need to specify which of the axes we want to plot on. In this case, this is a 1 by 1. It's just one, it is only one axis, we can just use ax.scatter. And then we need to specify the x range, the x data, the y data. Then we need to specify the x data and y data. Then all the other arguments like the color of the markers and what markers we want is optional. And we can also control the size of the marker, but those are optional arguments. Minimally, we'll need to specify the x data and the y data. So yeah, then scatter will be to plot that. Then we can also specify some error bars, which we use the error bar function. So x data, y data is the thing that you need to provide. And then also include the error that you want to include, which is your y error. And it's also possible to include x error to have error bars in the x direction as well. Then the format afterwards is just to, like I would say just put it as none, so that you have this function only to plot the error bars. Then you can use scatter to plot anything else you want. Like if you don't provide format as none, I think it will also plot for you the line, but then I would prefer to have different functions or different functions to do different things so that you know exactly what you're controlling. Like that's the way I would do it. But if you want to save one line, up to you, you can just omit none and then it will plot the line for you together there as well. Then the next thing we have is the ax.plot, which is just to which is like it will plot the lines and then connect the lines for you. Yeah, so you need to provide the x data and y data. The y data here, instead of putting in like a list of array like the previous one, I put in the function together with the arguments. And since I know that the function return me an array, this is a valid way to do it as well. Then we can specify the labels for the different axes, your y-axis and your x-axis, and then like put some limits as to like what is the range of y data we want to plot for, what is the range of x data we can plot for. Yeah, sorry. Yeah, it's a set x limit and set y limit. And then lastly, we need to call the function plt.show to show all of the plots, to show all of the figure that we define. Yeah, so if you see like this is what you will get. It's a bit big here. Like I can't show it. I can't show the entire figure on my screen because I zoom in, but you should be able to see it on your screen. Then the next example is just to show what happens if you want to plot multiple axes on one figure. So we need to specify in this case is 1 row, 2 columns. And then in this case, compared to the earlier example, since we are having multiple axes on a figure, we need to like the ax here will no longer be will be one variable by itself, but it will be a list containing all of the axes. So for the first one is so this is just to do for the first column and this is for the second column. Yeah, then you can go through the different arguments and see if it changes anything. Yeah, then there's 2 links that I provided above that show all the possible colors and all the possible marker types that you can have for your plots, your error bars, and for your scatter plots. Are there any questions at this point? Is it too fast? Yeah, if there's no problem, I think we can move on to the last part. Yeah, so for the last part, it's just a simple exercise to ask you to implement at least the curve fitting and the plotting that I went through just now. So So I have this polynomial function that I want you to fit. Yeah. So you can just try now. Then okay. So I hope everyone had the time to try the exercise. So like this exercise was specifically chosen because I know that without specifying the initial points and the bounds, or either or maybe one of them is sufficient. Like if you don't specify the initial points or bounds, it will not give you it will not give you the correct parameters. Like yeah, like this example I just chose it because of that. So in this case, it's sufficient to just provide the bounds for the parameters, and it will be able to give you a solution. Yeah. Then now maybe I just point out like for the bounds, right? You can see that I didn't include two lists. I put a number followed by a list. So in this case, if I just put one number here, I'm just telling it that okay, all of my lower bound I want it to be 0. So instead of specifying a list word with 0, it's sufficient to just put 1 0 there, and the function will interpret it as okay, all of my lower bound is 0. Yeah. So you can see that it works. Yeah. So I will just stop the recording here.